Good morning, ladies and gentlemen. Welcome to this second appointment of that hot topic of SMR and advanced reactors. Welcome, I'm Marco Ricotti, I'm professor of nuclear power plants in Politecnico di Milano University. And we are here with this second high-level panel of distinguished speakers after the high panel of this morning. We will deal with hot topics, as we told, about SMRs, but first of all, to have an introductory and complete picture on the topic of SMRs, I would like to invite Anissé Touré. He is a SMR product director of Tractable to offer us a quick but very precise overview about the SMRs. Please, Anissé.
Thank you, Marco. Right, I have this slide. So first of all, let me say that it's a real pleasure to be with you today and quite an honor to do the introductory part of such a prestigious panel. I doubt that anyone will be surprised to learn that I'm going to talk about small modular reactors today. What I'm not going to do is try to walk you through the diversity of more than 70 designs that exist out there. What I will try to share with you instead are some of the key elements that are needed to understand why we as an industry should believe in SMR and why we at Tractable came to the conclusion and to the vision that net zero needs SMRs. So we often talk about SMR as some new reactor technologies, but we believe that it's much more than that, actually. There is quite a wide variety of technologies, from light water technology that will be the market initiators of tomorrow to the second wave of generation 4 nuclear technologies. But what small and advanced modular reactors do have in common, and what sets them apart, is a business model. A business model that starts from the right question, and that came up with some pretty sensible answers. Question 1, how can we recreate financial appetite for nuclear investment, especially after the delays and cost overruns that we've known in the American and European new build? I guess everyone would agree that almost no private actors today can afford investment capex of tens of billions euros that are required to build the large nuclear reactors. But there are a multitude of private energy actors that are building projects in the 1 or 2 billion euros range. So this is, in my view, the most important driver why the nuclear industry is going smaller with SMR. Obviously, in addition to that, we'll need for SMR to rely on standardized and streamlined delivery model that can ensure cost competitivity, even to compensate the loss of economies of scale. Question 2, how can we recreate public trust in the nuclear industry? And I believe the SMR answer to that question is by making simpler machines. Simple enough to explain to the public, but also simpler to build. Machines that rely less on complex engineered features and more on natural phenomena in so-called passive systems. And I would say that this is the reason why I like more and more this upcoming definition of SMR as simpler, smaller, and standardized modular reactors. So the last and probably the most pressing question is that the SMR business model address is how can nuclear energy expand its role in the fight against climate change? And before addressing that last question, I'd like to share with you a few numbers to grasp the magnitude of the challenge net zero represents. especially when we are looking beyond electricity generation. So in 2009, the European heat market for the industry and district heating application was estimated to be about 3,000 terawatt-hour of thermal energy. That is the equivalent of near to 400 gigawatts of thermal power. And about two-thirds of that is heat that is produced below 550 degrees C, which means that it could be produced by nuclear reactors. We at Tractable have identified more than 100 industrial sites over the whole Europe that could potentially welcome SMRs. And although that number is huge, getting European industrial heat emission to zero would only reduce the worldwide greenhouse gas emission by about 2%. So that gives you quite a magnitude of the challenge we're facing. On hydrogen now, because this is quite becoming a trendy topic, the IEA estimates that to reach carbon neutrality by 2050, we'll need to quadruple the worldwide supply of hydrogen by 2050, and to make it low-carbon hydrogen on top of that. Assuming that carbon capture is effective enough so that blue hydrogen can produce half of the hydrogen that is needed, we would still require about more than 5,000 terawatt-hour of clean electricity dedicated to the production of hydrogen. I don't know if you realize what that number means, but it's more than 20% of the current worldwide electricity production. Just mind-blowing numbers. So I don't know about you, but these numbers make it quite obvious to me that we'll need to expand the role of nuclear energy if we want to reach zero carbon. And this is why net zero needs SMR. In these pictures, what you can see summarizes quite well the vision that Tractable has built over the last 3 years. In a nutshell, we believe SMR will become cornerstones of the complex energy systems of tomorrow. Through their ability to provide heat to keep us warm in the winter days, through their ability to balance the intermittency of renewables on the grid, through their ability to help with water scarcity problems that some of our countries are facing, through the ability to produce the hydrogen and e-fuels we'll need to farm our land, to power our ships, and to power our planes. And ultimately, through their ability to supply the process heat we'll need to power our industries and to make things. So obviously you're going to say to me, well, this is just a dream. And I would agree with you. But this is what is needed. And we, as an industry, will need to make a robust plan to make that vision into reality and make it happen by the time the world needs it, which is not 20 years from now, but 10 years from now. So I will leave you with a list of key questions, key success and failure factors that the SMR industry needs to address. One, origin safety case. technology readiness of SMRs and achieve broad market deployment by the 2030s. Question 3, how will SMR achieve the required cost competitivity that is currently claimed by technology developers? And how do we make sure that first-of-a-kind project will be built on time and on budget to make sure that they are not killing hopes for any subsequent projects? And lastly, how do we create a supportive environment for first mover to create an SMR market? So now that I've done the easy part, which is asking the tough question, I will leave it to our panelists to try and do the hard part, which is try and answering them. So with that, I thank you, and I'll give the floor back to Marco. Thank you.
Thank you, Anissé, for a very comprehensive, even if short in time, presentation. You help us to give a picture of this issue. The opportunities are there. The promises, I would say, are here. Are we ready for the SMR and advanced and modular reactors to get the dream real? The competition is going to be tough. The scenario is complex. We should be trained and prepared for what out there? What are the SMR and the AMR features and opportunities to be exploited and the challenges to be faced? What is the strategy? These are some questions that may arise while dealing with such a hot topic today. We are glad and honored to host our prominent, distinguished, and leading actors on that scenario. The rules of the game are simple. I will ask you a question. I will give you, each of you, 5 minutes to answer. Then we have a final round of quick question, quick answer, and in between, we'll see according to the time, I will ask you something more. I will introduce our guests one by one, first starting with Renaud Crassou. Engineering background, he graduated École Polytechnique with a PhD in climate and energy economics. Very perfect topic. 10 years of research in climate economics, energy scenarios, and public policy assessment. He joined EDF, senior economist, operation manager of hydro dams, director of engineering center for conventional island of EDF and PPs. So now SMRs. Then Jay Willeman. He's president and CEO of GE Hitachi Nuclear Energy. He served as a president since 2015. I remember that GE is a global leader in new plant technology, fuels, and services. He has more than 30 years of energy industry experience, and he's led many global teams to success across the energy spectrum. He started GE career in 1994 with the company Nuclear Business, and before joining GE, he was a nuclear fuel engineer and commercial manager for Southern Nuclear. Let me be a little bit more provocative to you. You are leading companies in the nuclear sector with decades of experience and leadership in the field of large-size PWRs, EDF, and BWRs, GE Hitachi. So why SMRs? And what is new or different in the SMR technology you are proposing and developing? Renaud.
Thank you, Marco. Messieurs, dames, bonjour, ladies and gentlemen. First of all, I'm very pleased and honored to take part in this roundtable. I'm sure this will give us a first-hand look at the dynamism and hope which is behind all these SMRs concepts. And for us, EDF, the answer is clear. We have two very good reasons to engage strongly in the development of an SMR. The first one is obviously climate, and the second is business. So the answer is quite simple. I think it's okay, and I can transfer the speech to my neighbor. First reason, climate urgency. SMRs are on the way to become a new and complementary option for expanding the use of nuclear energy to decarbonize and to accelerate the fight against climate change. And at EDF, it is at the center of our raison d'être to offer as many options to decarbonize energy industrial systems as we can. So the perspective of SMRs attract new clients that were not used to nuclear before, big industrial players for their own needs, small and medium utilities, remote communities in Europe or in Canada. And it opens very interesting perspective, as Anisse has shown, about CO2-free hydrogen, desalinization, or district heating, or even capture and reuse of CO2 if we want to have negative emissions up to 2050, but also after that. So we cannot but trying to find the best options to answer to this large amounts of free CO2 energy needs. It brings me to the second reason, it's business. The future market potential for SMRs is huge, and we have very serious assets to put forward in this future market. Let me give a very simple figure as an example. If you consider only nuclear-friendly countries in the world, they have more than 3,000 coal units to be replaced in the next 3 decades, and replaced by CO2-free electricity. Notwithstanding the necessary increase in CO2 electricity if we substitute largely fossil fuel to electricity. Just think that nuclear will only take a small part of that alongside with renewables. You still have hundreds of SMRs to build around the world in 20 years. So it's a complete change in paradigm, I think, for the nuclear industry to produce so many units in series around the world. These two reasons led us to develop the new world SMR model, which is a 340 megawatts Gen 3 plus integrated PWR. You know very well that integrated PWR are not new, because I think the first one was on the Otto Hahn ship in Germany in 1968, so it's a long story. But now there is a momentum for them. And we choose this design, this Gen 3 design, because fighting climate change is really an urgency between now and 2050. A short time to market is really key in that story, and we have to be ready between now and 2030. Even if the emergence of a significant pipeline of projects will take some time on the demand side. Because nuclear, be it small and modular, it will still require coherent energy strategy, roadmap, public consultation, local acceptance, and a guaranteed safety and security environment. That's why we design New World with a constant objective to define the optimal mix between highly proven technologies and minimal specific breakthrough innovation for SMRs. Still, there are innovation in the design of the reactor itself, but we also have deep innovation in the standardization and the modularization approach of the whole plant, and also how the plant will be inserted in its environment, peri-urban environment, desertic, or other environments. We want New World to be available for commercialization as soon as possible, let's say in 2025, in parallel of the detailed design and the pre-assembly of our reference plant in France. Our planning is to pour the first concrete of the reference plant in 2030 in France. And that is not a marketing claim. This is a real industrial planning for the New World project. Second, the output of 340 megawatts with 2 reactors in one plant. This will target explicitly the replacement of middle-sized coal units, even if multi-uses is also embarked by design for cogeneration for heat, hydrogen production, or even desalinization. Third, but not least, we have all the skills and know-how to develop, operate, or maintenance, or dismantle PWR by rallying on EDF and our strong partners, and on so many industrials players in France and in Europe that are willing to participate and help us. While we try to keep an agile and small project team for New World, Our industrial scheme and our supply chain are already existing, robust, backed with major, strong, and long-standing industrial players, and we think that it is really important to do that. The new world design is driven by our future clients' needs. As an integrated PWA, it will embark progress on safety by design. It will be simple, modular, standardized, and we already have a step-by-step pre-licensing discussion with our safety authority. We connect more and more with potential clients abroad to ensure that we develop a product that it is a suitable international standard design. And Jean-Bernard Lévy just announced this morning a new step forward as we create a very high-level international advisory board for New World, gathering experts from utilities, nuclear industry, who will make recommendations and help us to choose the right options. I will conclude. We will indeed participate to this very exciting momentum for SMRs around the world. With our colleagues and partners in Europe, we will continue to direct our efforts and determination toward designing a competitive and ultra-safe New World products. And because the climate deserves it, because we have the skills to do it, and because the business is likely to be great.
Thank you. Thank you, Renaud. Jay.
So thank you for that question. I would bet that you are correct. When you think about GE and nuclear, you think about large BWRs. But if I step back to when we started in the middle 1950s, our serial number 1 licensed in the US was 5 megawatts, which today we would be talking about microreactors. And then, of course, the evolution of BWR 1s and 2s really were, back then, small. And, of course, now we've come up to the gigawatt scale. But in looking at the difficulties of the larger and larger plants to construct and hit cost targets, we went back in 2017 and just stopped and asked the customers, what do you really need to get a nuclear new build going again? And it all came down to cost, competitiveness. So I, asked a few of our engineers to think about that, and after buying a lot of Red Bull and pizza, they came up with some great innovations for taking our NRC licensed ESBWR and actually not just making it smaller, but having some very innovative design changes to be able to simplify. So for our Tractable speaker, thank you for that. I could put the GE logo on there and it'd be exactly what I would say for simple, small as well. So that's really key to us. SMRs are needed because I think everybody in here would agree nuclear has to be part of the solution for net zero, whether it's 2035, 2050, whatever that is. So nuclear has to have a seat at the table, but we have to earn our seat at the table through cost and cost targets and being competitive. No longer can a private business put up tens of billions of dollars to build a large reactor. So one of our goals was to hit an overnight cost in the 1 billion range, something that was doable for a lot of utilities and industrials out there as well. But in addition to that, the LCOE needed to be competitive with combined cycle gas and certainly the renewables that are out there as well. So that's what we set out to do in working with the BWR X300. And we're talking to many different people in different areas, the US, Canada, and in Europe. And we believe that we can bring the first BWR X300 online by 2028, and that's our target. Again, cost is critical, but it's also the experience that we've had to bring certainty to that outcome. That's extremely important, is bringing certainty to the outcome. A lot of the players that are out there, and some in the audience today, some not, it doesn't stop when you sign that LOI or MOU. It doesn't stop when you're not done when you sign that contract. You're not done when you get your construction permit. You're not done when you get first concrete, or you get the operating permit, or you load fuel, or you get first criticality, or whatever. You're not done. You're done when your equipment and systems reliability gives you that capacity factor that's 90+%. You're done when your demonstrated fuel gives you great economics and the reliability that has been learned over many, many years. You're done when you can prove short outages that are very efficient and let the owner operate that asset, right? So that's what is really, really critical to me, is having the experience, having the design to cost mentality, and executing to get things done. So to all the other colleagues out there, I would say it's time to get it done. It's time to get it done. We also believe in Gen 4 technology. We're a partner with TerraPower on the Natrium design. Really a best athlete between their design and our Prism sodium fast reactor as well. So we see a time for that evolution as well to help contribute to net zero. But we're excited to be here and excited about nuclear's place in the energy transition. GE is a broader team, has many different technologies. I think it's about making things available for customers that fits their needs, whether it's wind or solar or hydro or gas power in the near term as well for the transition. So we're excited to be able to do that, and thank you very much for having me on the panel today.
Thank you. Thank you very much, Jay. I'm very pleased, I'm very glad to listen by you, Renaud and Jay, that the timing is perfectly in line with what emerged this morning during the keynote. So 2030, we need to have the technology ready to be deployed. An important contribution is coming also from Rosatom. Now let us move to Evgeny Pakermanov. He's president of Rosatom Overseas, the company which promotes the integrated solution of the Russian design nuclear power plant construction projects abroad. He's president since 2015, and before, since 2003, he was top manager in different positions, general director, director of strategic development, finance and economic director in other Rosatom subsidiaries, like Atomenergomash, in general in the heavy equipment and manufacturing industries. So, Evgeny, Rosatom owns probably the largest portfolio of SMR concepts and design, not only SMRs, also advanced modular reactors, from the barge-mounted, the academic Lomonosov, the KLT-40S, to icebreakers, to land-based. Now you are developing Rhythm 200. You are building Brest OD300. So why that diversification? What are the potential markets you are envisaging for the SMRs and AMRs?
Thank you, Marco, and thank all of you who are interested today in this discussion about SMR's development. Yes, you're absolutely right. We in Rosatom, as our colleagues from GE, from EDF, we have a very long history of developing and operating of different types of SMRs. And today we do have in our portfolio all type of technologies, but for sure it's not possible to develop all of them and to realize projects for a lot of types of different technologies. So we should concentrate on several which, in our opinion, have best future, and I'll try to give you a clear picture of our understanding on what technologies we are working now today. I'd like to start by saying that we have a long history of developing small reactors for marine applications. Due to that fact that Russia has a unique geographical position stretching along over 24,000 kilometers of the Arctic Ocean, we had to develop for decades our unique nuclear icebreaker fleet. And when the energy market clearly showed its needs in small reactors for energy generation, it was obvious for us to use our experience and to create a floating nuclear power plant. Thus, we have constructed the first-of-a-kind floating nuclear power plant, Academic Lomonosov, with KLT 40S reactors, 35 megawatts each. And it was commissioned in 2019, and today we have 2 years of very successful operation. And in this case, we can say that we done. Our next step, also in marine application, was new SMRs, which is called RITM series. It is also a proven and reliable technology. It is a little bit bigger capacity, 55 megawatts, longer life cycle period, and longer fuel period. And we already manufactured 6 of these RITM series reactors. 2 of them are in operation today on our new nuclear icebreaker, and 2 of them will be commissioned before the end of this year. So today we see a great interest for floating nuclear power plants. And we have already signed an agreement, a contract, and we started the construction of 4 modernized floating NPP with the RITM reactors, which will be commissioned in the middle of 20th, and I think it's also a big success. For our clients, it's a turnkey solution with less construction works, at the site, I mean, with easier decommissioning, and this is very important for potential host countries. And today we see growing interest for floating and PP worldwide. Together with developing floating SMRs, we decided to use the same type of reactors and adapt it for land-based SMR. So we already work on the FOAK project in Yakutia, also in the north of Russia. And we are going to commission the first-of-a-kind land-based nuclear power plant in 2027. I am quite proud to say that we are ready to offer these proven and tested SMR solutions, both floating and land-based, to the international market. And at the same time, we are ready to move further, and now we work on next generations. As you know, today we are working on the very interesting project named Brest 300. It is a fast lead-cooled reactor. And this year we had first concrete. We are going to commission this reactor in 2026. And it will be the part of a big project of the closure of the fuel cycle. And I believe this is very important for the development of the whole nuclear industry. And hopefully it will be very successful and very attractive for our partners in the world. So I'm sure that this decade we will witness the world next generation innovative lead-cooled reactors with unique features. Thank you.
Thank you. Thank you, Evgeny. So 2027, 2028, 2030, Simon. The competition is tough. Let me introduce Simon Newton, Chief Commercial Officer for Moltex Energy, covering its operations in both UK and Canada. He has worked for Moltex for 3 years, having spent his earlier career in sales and marketing roles in the IT and the telecommunication industry. He has a degree in physics from Bristol University, but says that it was a long time ago and almost all forgotten, but now fully involved in nuclear industry. Simon.
Thanks, Marco. Thanks very much, and thanks everyone for the opportunity to be here. I think I represent the kind of advanced reactor community to some extent. The term SMR often applied to small pressurized water reactors, and I think Anissé referred to advanced reactors as well, which is where we see ourselves. So we're one of a number of reactors cooled by other things, including lead, for instance. And the opportunities for that technology, as Anissé laid out earlier on, are simply enormous. If you think 2/3 of the heat used in the world is under 550 degrees C, that's as it happens, the output temperature of our reactor. And the other third available through the production of hydrogen, perhaps, or indeed electricity. So we see the SMR-AR category as allowing nuclear to address pretty much the entirety of the world's primary energy production on all scales, gigawatt, 100 megawatt, 10 megawatt. And when you think that right now, nuclear power is what, 400 gigawatts worldwide? It's about 10% of electricity production. Electricity is about 20% of worldwide energy use. So we are contributing 2% of the energy that the world uses right now. So as we would have said in my previous marketing career, I don't think we're constrained by a lack of opportunity here, right? I guess the question is, what are we constrained by, though? And there are a number of things there, I think. Manufacturing construction time periods are one, for sure. And we have to do something about that. Permitting time periods are another. The availability of sites, the licensing of sites, and so forth. As an example, the environmental impact assessment process in Canada, where we operate, takes 6 years. And it seems difficult to imagine the sort of scale of rollout that we're discussing if time periods like that continue. There's only 30 years to go, right? And so those constraints of construction times, of licensing times, also lead to another constraint we have, which is investment. Early stage investment. Because many of the SMR vendors and practically all of the advanced reactor vendors are at the very early stage and need visionary investors in order to get them to the point where they can have real projects. So those are the constraints that we have to work within. And I think if we're able to overcome those, which we're all trying very hard to do, then we have the most enormous potential to help solve the world's energy problems on a scale that's pretty much unimaginable, really. Of course, we already all know that, so we should probably also spend less time convincing ourselves of that fact and more time talking to people outside the nuclear industry and selling them on the idea too. Thanks very much.
Thanks a lot, Simon. Now let us move to a utility. Dominique Minière, nuclear president of Ontario Power Generation, 40 years of experience in nuclear operation and engineering, the first 37 years in EDF, from young engineer up to chief operating officer, with international exposure, 4 years in China, and a lot of contribution inside WNE. After Fukushima, he designed globally the FARM, the Nuclear Fast Action Force. And then in the last 3 years, he joined Ontario Power Generation in Canada, from operation to strategy with a climate action plan set up now, and the alignment of all the Canadian industry around and shared way to develop new nuclear. Key topics, new nuclear development and international cooperation and development. Dominique, why a utility could be attracted, in quotes, by the SMR solution, and what is the SMR business model that could be of interest for a utility?
So thank you. I'm very pleased to be with you today. And just to try to answer quickly to your questions, I think every country now and every political parties in every country is aligned on one goal, to be net zero by 2050. Because of the climate change issue, because of the, I would say, the challenges we have in front of us. But challenges when you are in business means also opportunities, because it means that you have to develop solutions, and solutions is always opportunities to develop your business. And so really we are really concentrating now to develop hydro, renewables and nuclear in Canada, in OPG, in Ontario Power Generations. When we have a look of the needs we have in front of us, we have needs in Ontario and Canada. By the end of the 20s, we are completely convinced that we need a first of a kind of around 300, 400 megawatt for Ontario, but also to demonstrate that we can do on time and on budget, enabling the possibility to replace coal power stations, both in western provinces of Canada, but also more generally abroad, and enable development of underdeveloped countries for the time being, because they will need 300, 400 megawatt. So we do think that the range of 300, 400 megawatt is probably the right range for SMR. So and I'm convinced in the meantime that we have nothing successful on time and on budget regarding new nuclear before 2030. There is no future for nuclear. No one will invest in nuclear if you have not successful project on time and on budget. I'm convinced of that. So what do we need? We need really not only a new nuclear plant, we need new kind of nuclear. It will not be a new nuclear power station, it will be new nuclear. I think it's very important. Why? Because thanks to SMR, we can do ultra-safe reactors. To a point that, for example, if I take the example of light water reactors, when it goes to residual heat removing, you know that we have really an operator delay of 20 minutes of 1 hour. With a lot of SMRs now, you can have an operator doing nothing for a lot of days, 7 days typically, without any impact on an external environment. So it's very important because with such safety features, you are able to convince the public that you can, and mainly the Nuclear Safety Authority, that you can limit the exclusion protection zone, the equivalent of zone PPI in France, to the fences of the power stations. It means that for the public, whatever the event inside the reactor, you will have no consequences, no need to take any pills, no need to evacuate your home, you will be able to stay there. So it's really new nuclear. It's really a new step of nuclear. So that's very important. So with such design features, the main challenge we have in front of us is to replace the S of small modular reactors by S like simple modular reactors. It's very important. So we should be able to design very simply. For example, no needs of diesels, no need of external water, no needs of complex INC to do that. So it's very important because if you are designing simple, you are enabling to construct simple too. So effectively more opportunity to deliver on time and on budget. And if we are able to design simple, you have a possible LCOE, a possible cost, lower than other clean solution with a fleet of only several SMR delivering, or around 1,200 megawatts, so very quickly, as a matter of fact. So I heard about the need for international harmonizations. Why to speak about international harmonization? We don't speak about international harmonization for large water reactors, so why for small modular reactors? Because there is a belief, I have heard even this morning, that we need 100 SMR to be competitive. When you have a look on that, a real deep look on that, the question is it facts or belief? From our perspective, it's beliefs. It's not facts. You can go to a very competitive thing only with few of them. So of course, it's better to have a certain level of harmonizations regarding nuclear, mainly between the countries which are really believing in SMR. But when it goes to the race, when you go to the race between international harmonizations or climate change issue, pushed by the young generation, I will really bet on the climate change issue. We have to focus on climate change issue and to develop quickly, on time and on budget, nuclear projects. That's what I think, at least. So after that, what we are now, so in Canada, we have aligned all the utilities around a roadmap. The roadmap is quite simple. We need a stream 1, 300, 400 megawatt reactors, on-grid reactors before the end of the decade. Mid of the 30s, probably stream 2, more generation 4 reactors, more developed reactors. I think it's very needed. And a stream 3 or so of very simple reactors, 5 megawatt for remote communities and mining is very important for us in Canada. So in OPG, we are working on stream 1 and on stream 3. And on stream 1 is 300, 400 megawatt reactors that could be connected to the grid by the end of the decade. We were in the way to do the final. We have started with 100, not 70, as I heard this morning, but more than 100 designs which are already on the table today. We have gone downsized to 10, then to 7, then to 3. And then for the last year, we have concentrated on the 3 of them, pushing them to develop their design, and in order to have some good idea of which technology we could focus on. Normally, I should have told you that we are waiting for the end of the year to do the final selections, but we are in a hurry, so we have selected yesterday. So there will be a press release at 2 o'clock Paris time, it's 8 o'clock Toronto time today to announce that we will concentrate on one developer in the coming years. This developer is close to me. It will be GE Hitachi BWR X300. So I can tell you that we'll concentrate on that. And we have a very, very, very tight schedule because by the end of the 2022, we would like to be able to send a license to construct application to our CNSC, our Nuclear Safety Authority. Then in 2023 and 24 to go on discussing the licensing, but in the meantime, to finish the design. I will go back to this point after. And then to get to class 4 estimate by the end of the 2022. We will have also to develop a commercial path with the developer, with the engineering firm, with the constructor, in order to align all the people around our purpose, our target, because I like partnerships. In my life, I've heard this word very many times. I like love, but I prefer evidence of love. So we will ask all these people to put not only profit at risk, but also equity at risk with us, in order the interest of the projects will be greater than their own interest, because it's something I've learned. And in fact, in 2023, 2024, we will go on doing the design, and we will are really looking for a class 3 estimate by end of 2024, beginning of 2025. It's only when we'll have that we will really decide to build or not to build, because if we don't think we could build it on a time and on budget, we will not do it. We really would like to do that on time and on budget. So there is a lot of pressure on our colleagues to do that, but it's very important. Why? Because we cannot say that we have been successful so far in the Western world regarding new nuclear. We have to be lucid. We have not been successful. We have tripled the budget. We have tripled the timeline. You will find nobody in the financial community who will support nuclear if we are not developing on time and a budget a project. So why do we think we could be better in Ontario power generation than the other ones and big utilities? Mainly because when you have a look at the 5 main reasons what it has failed in the world, I will say we do think that we could be in a better situation with what we are doing. Why? Because one of the first reasons was a weak supply chain. Weak supply chain, as people have not built for a long period of time. In Ontario, due to we have now a strong supply chain due to the refurbishment of CANDU fleet. Because of refurbishment of CANDU fleet, we have now a strong supply chain in Canada, and which will decrease this workload by 2024. So it's very aligned with our timeline on SMR, because if we start construction in 2024, it's very aligned. Second point is weak project teams. In fact, as a matter of fact, in Ontario, thanks to refurbishment, we have delivered a project people have maybe not heard about, but it's a refurbishment of the first CANDU reactors. For the first time in Canada, due on time, delivered on time and on budget, on the high confidential schedule and high confidential budget. It's 44 months of constructions, $5 billion Canadian of investment, delivered on time and on budget by our project team. And on the second one, we have learned from the first one, we are not only on the schedule, on the high confidential schedule, we are not on the working schedule, we are ahead of the working schedule. So we can tell you, we have a strong project teams now in Canada, in Ontario Power Generation. Third point is a complex design. So a lot of these large reactors have complex designs. If we are really able to design simple, we will be able to really to have a possibility to deliver on time and on budget. Fourth point is the beginning of construction with design not finished. So when you try to design and to build your house with only 30% of the drawings, you can expect some difficulties, and it was like that on large water reactors. So we have a real commitment to start the construction only if the detailed design is finished. I have told the main developers before, including Jay, that I accept that the color of the paint of the wall will not be decided, but that's the only point I will accept. And a difficult relationship with nuclear safety authorities. Thanks to the refurbishment, we have been able to establish rules of the games with our nuclear safety authority, with clear points, all points, with some games of the rule when we should deliver what we have to deliver, sometimes before, and if we deliver this time before, CNSC is committing to give us his answer on time and on schedule compared to our schedule. That's why we have succeeded also on refurbishment, because of protocol, clear rules of the game with CNSC, and we will really go on this way. It's very important for the future.
Thank you. Thank you, Dominique. Thank you also for sharing with us this important news, really. Now, Rauli Partanen is an independent, award-winning author and analyst on energy and the environment. His book, titled Climate Gamble, has been published in 7 languages, and last year he received an award from the Finnish Nuclear Society for his efforts in communicating nuclear and climate issues in both Finland and abroad. Currently, Rauli runs a non-profit think tank called Think Atom, which studies and popularizes the ways in which nuclear technology can be used to decarbonize different sectors more efficiently. Rauli, why public opinion should trust, in quotes, SMRs? Moreover, what do you think? Are the other markets and the other industrial sectors like cogeneration, renewables, hydrogen, mobility, already ready for the SMRs?
Well, thank you. Let's just start by saying that what an absolute honor and pleasure to be here, talking with you, so many people. And what a big question, very complex. I'll start at the end, because that's a simple one. Is the industry ready for SMRs, like other industries than the nuclear industry? No, not really. They're slowly becoming aware that these things exist and that there are many kinds and many sizes. And obviously, by being ready, you would have these plant operators, like maybe a coal plant operator somewhere, or a refinery, or a steel mill, a chemical plant, trying to buy one if they were kind of ready. But I guess that it'll be a long way for them to get ready, because when they get interested in nuclear, they also need to open the can of worms of nuclear regulation and all of that, which might be a little bit hard to kind of swallow at first. But we have to help them. And that is actually what I do through Think Atom, and what people like Kirsty Gogan do. They try to make it easier for the industry to recognize what can be done. For example, just recently I made this brochure, small nuclear reactors and where to use them. You can have this and some of my other studies by coming talk to me after this, or coming to the Finnish pavilion. So there's a plug there. But yeah, no, they're not ready, but the situation was much worse 2 years ago and 3 years ago, so now they are becoming more and more ready, and we need to help them. Those industrial users, the buyers, the customers are the people that we need to talk, or the industry needs to talk to, even more than directly going to politicians or the public, because I mean the nuclear industry can talk all day about how it's needed in the climate project and how it's needed to decarbonize. But unless you have actual businesses and customers telling the politicians that we would like to buy one of these, can we have a regulation for that so that we can actually do that? That's the situation that you want to be, because then there is someone else than the nuclear industry saying that these guys are important. Right. Then there was this other question, which was a bit bigger. I'm not tweeting, by the way. I just have some notes here, so I don't forget anything. So why should the public trust small reactors? And you can look at it multiple ways. Can they trust that they are real and can be deployed? I mean, the West, we don't have a great track record of deploying new nuclear in the last 20 years. So how can you kind of have the people trust that, okay, this time is different. This time we can deliver. And that's a big ask, and that's why you need to talk to the industry, the customers, and stuff like that. Can they trust that these SMRs are safe? I'll just give one hint, but probably a lot of industry people here. I'll give one hint. The less you talk about how you improve the safety even more today than it was yesterday, the more the people can trust you. Whenever you talk about improving safety, you bring this image of fear and risk and danger into normal people's mind. So don't lead with that in your communications. So the other day, we went to a nice restaurant in central Paris. And imagine if the waiter would have started with describing me how they have prevented rats from entering the kitchen, or how they've been operating 18 months without any food poisonings and certificates, and how they are constantly improving their safety. I probably would have, well, maybe I would have even stayed there, but most people would have gone to a different restaurant. So you need to talk about the benefits and what you can do with this, and not the safety. It's an important part of the internal safety culture. I'm not saying that, but the public is not interested. Don't lead with that. Then there's the thing that, should the people trust that these reactors are actually needed? And this again goes to the new use cases and the industry applications that SMRs can have. That, I mean, I've been writing about this for more than 10 years, and I haven't found many other good solutions for producing 500 degrees steam reliably 24/7 without emissions. So that's a story that we need to tell to the people, is that these are needed, and you better believe that. And then there's of course that, can they trust that these will be economical? It's this time is different. How can you make a smaller reactor cheaper than a large one? And that's a tough topic. But you just have to explain it in understandable ways. I mean, people understand when you tell them about serial production versus one-time construction, or you can maybe talk about how you can use much more productive environments like shipyards or manufacturing plants to do these reactors, and how you can enable that serial production with streamlined regulation and harmonizing the safety standards and whatever. So yeah, it's a big complex question that we need to kind of push at every front all the time, so that everything can move little by little by little. And it is moving, so good work, us.
Thank you, Rauli. And now, last but not least, Rumina Velshi. She is president of the Canadian Nuclear Safety Commission, president and chief executive officer of the CNSC, was appointed in August 2018. Key priorities for Rumina are innovation and acceleration of technological change, collaboration to harmonize regulatory reviews, and to gain and enhance public trust, but also promotion of careers in science, technology, engineering, and mathematics, especially for young women. And in February 2020, Ms. Qureshi was appointed chairperson of the Commission on Safety Standards, established by the IAEA, for a 4-year term. So, Romina, you were cited, not you personally, but the role of safety authorities was cited several times this morning. It is really a key role in this picture. So for safety authorities, is there also a new paradigm for licensing process? Some mention simplification, for example. And what about international harmonization?
Thank you very much, Marco, for the question and giving me the opportunity to give the regulator's perspective on the challenges and issues that frankly have shown up a number of times over the last 3 days around streamlining, simplification, harmonization. So first of all, I'm really happy to be here and to share this podium. And I'll respond to that wearing 2 hats. One as the head regulator for the Canadian Nuclear Safety Commission, but also in my role as the chair of the Commission of Safety Standards of the IAEA. So let me first start off by talking about how Canada is making sure that we, the regulator, are not an unnecessary impediment to the introduction of new technologies like SMRs or advanced reactors, and how we have been getting into a state of readiness for that. So one of the things we have in Canada is a pre-licensing process called a vendor design review process. So Moltex, GE, Hitachi, for instance, along with about 10 other proponents, are participating in this VDR process. And it's a way for the regulator to identify if there are any showstoppers to the licensing of that technology. Also gives the proponent an opportunity to learn how the regulatory approach is in Canada. It is a little different, and for us, the regulator, to learn about the technology as well. So the VDR process, very popular, very effective. The second one that I really want to talk about is our regulatory framework. What is maybe not unique, but it is a bit special about the Canadian regulatory framework is that it is performance-based. It is not prescriptive. It leaves it up to the proponent to demonstrate how they're going to meet our goals and objectives, which allows for much greater innovation and flexibility. We have also made sure that it's technology neutral, it's risk-informed, it's a graded approach so that the risks and the requirements match. And as many have said, these new SMRs are a new beast altogether. So regulatory requirements that were set up for these large pressurized water reactors, CANDU reactors in our case, not necessarily applicable to this new beast. And an analogy that's often given is using the requirements of a mainframe computer and using it for a laptop, for instance, an iPad, just doesn't make it. So we've modernized our regulatory framework. We've had international peers look at our regulatory framework to make sure that we're not imposing a heavy burden, unjustified set of requirements to proponents, but never, ever wanting to compromise on safety, security, or safeguards. And we've got that stamp of the champ from the International Regulatory Review Service done by the IAEA 2 years ago. And the third area of our focus is international collaboration. We recognized a number of years ago that, as we've heard today, but we were 3 years ahead, with climate urgency, with energy security, what the future may indeed be is a global fleet of SMRs, maybe thousands of reactors in over 100 countries, new countries that have never had to deal with nuclear before. And in order for that to succeed, both from a safety perspective, which is critical to the nuclear regulator, to the safety authorities. Because as we say in our industry, an accident anywhere is an accident everywhere, no geographical boundaries. It is imperative that those safety standards get maintained. But it is also imperative, this is a very sophisticated technology, that we do what is needed to enable these emerging countries to introduce these SMRs effectively and safely. And so what we have, we started a bit small. In 2019, I signed a memorandum of cooperation with my counterpart in the United States, the United States Nuclear Regulatory Commission, where we said we would do joint reviews, maybe joint assessments, and see how that works. And frankly, it's worked extremely well. And in 2020, we then did a similar arrangement with the United Kingdom's Office of the Nuclear Regulator, where we've said, let's do some joint assessments, and now we're actually looking towards a tripartite arrangement of the 3 countries. We want to start small with like-minded regulators, and to see with the ultimate goal, and as we've heard this panel and previous panels, that what is needed is a standardized design for SMRs to be cost-effective, to be deployed safely around the world. The design has to be standard. And in order to have a standard design, you need harmonization of not only just regulatory requirements, there seems to be so much focus on that, but it's also industry standards. And it's not only just requirements, but it's also the licensing approach, or the licensing basis and the licensing process itself. So ultimately, my vision is that we get to something like a certification of a design. And if 3 mature, or maybe more, regulators that are respected say this particular design meets our requirements, I think it would give a lot of comfort to a lot of other regulators to accept that and build on that, and maybe add their own unique country-specific requirements. So that's what we're working towards. I think we're building a lot of momentum, and with the announcement today that we have just heard from OPG, I believe we actually now have a specific technology that the 3 of us can work on to see, can we assess this jointly and come up with our joint assessment on how well does this particular technology meet our requirements. And again, as I said, I think that will greatly help the safe and fast deployment of these technologies. So this is not just an issue for regulators. I think the 3 of us have taken, I believe, a pretty bold state and move towards this. This is really for policymakers, it is for industry, it's for governments to make sure that the right enabling environment is created for this to succeed. And so my last point is, it's not just standardization, it's not just harmonization. I believe what's required is a review of the international framework on how we oversee nuclear in this world. Right now, you know, we've got 440 plus reactors in 40 countries. And as you said, Marco, shift in paradigm is required when you're going to have thousands of reactors in over 100 countries. What kind of oversight is really needed? What kind of international technical support is needed for these new emerging countries? What kind of trade agreements need to be there to allow for parts to move, and for, you know, as we said, a loaded reactor to, as we heard this morning, to be brought to a country and taken off? What is the enabling framework that's required? And that work really needs to happen, to have happened a few years ago, but it needs to have started, and we need to make sure that that is happening. So, some thoughts for us to consider. Thank you.
Thank you, Romina. I would like to do like that. You triggered a couple of questions to my mind. I would like to have a very, very quick roundtable, then we will go with the last question. One topic that is typically outside of the radar is human resources. I would like to ask Rauli and Romina to share some quick, let's say, thought about how to to help the industry, the communities, the academics, and to prepare for the new workforce, to attract also brilliant human resources to this issue. Please,
Should
Ravi.
I start? Well, human resources, yeah, I think that's one of the big bottlenecks that we should discuss a bit more in the nuclear industry. People are getting older, the first like pioneers in the 70s and 80s, retiring, and then we would need to expand like dramatically into new technologies and new scale of production. And those people, I mean, you can't force, at least not yet, people to go and study nuclear engineering or some other related field. So we really need to get the public and people and the media and the storytellers out there excited about the opportunities and benefits and what can be done with. And for that, I think SMRs and advanced reactors are a great tool. That's how I got involved in all this. I got excited about the possibility of a fast reactor, and then I started looking into and finally I found out that, okay, wait, the big current light water reactors are quite cool as well. So we need to get everybody, most people, more and more excited about this and then deliver, have those programs for them to go to study and become professionals.
Thank you. Romina.
Thank you. And as you said in your introduction, one of my priority areas is promoting STEM careers, particularly among young women. And my Canadian counterparts will know how active I've been on that front, not only in Canada, but internationally. I think the face of nuclear has to change, and it has to change very soon. This may be totally inappropriate, but I want to say this anyway, because I want to take this opportunity to say so. So there was a meeting that DG Grossi set up with a group called the Group of Vienna in September. Some of you on this stage may have been at that meeting. And so there was a photograph of this group that met. These are industry leaders in nuclear where they talked about how are we going to meet the climate change challenge that we have. And so I showed that photograph to a number of colleagues, friends of mine. And you know what the first observation was? These are all men, all old men. And that's the face of this industry that is seen, and that has to change for a number of reasons. One, as Rauli just said, we need greater innovation, and we know diversity brings greater innovation. From a safety perspective, different perspectives, diverse perspectives mean better safety outcomes. So I'm a big supporter of that. And the third one, also a big reason why we need more voices around the table, certainly more women around the table, is the strongest opponents of nuclear tend to be women. And when your messenger is not someone they can relate to, it impacts their acceptability of what the message is. So just a different angle from what Rauli has said. I think we need more diversity in this sector and young people, but different perspectives as well. So, and I know there is progress being made, just as we're talking about deploy for SMRs that we heard today. I think we need to accelerate that change as well.
Thank you. Thank you very much. Now, let me try to do that. Before the last round of questions, I would like to ask you a very, very quick answer about this topic that Romina triggered in my mind. Harmonization, standardization, international collaboration, supply chain. What is, in your opinion, I'm asking to Renaud, Jay, Dominique, Eugenie, and Simon, what is the most important priority or issue to be addressed for supporting the supply chain that could be able to work at the international environment?
Well, I think, as Dominique has said, we in Canada or in Europe, I think, have a supply chain which is in much better form than a few years ago, and that is really to support both big plants, concrete projects, and also the development of SMRs. So I know we can rely on everybody in this room and in this exhibition. Probably the challenge is for SMR is to change our mind, to set a real modularized plant, because it changed a lot of things in terms of design, preparing the equipment, supply, preparing the assembly line and optimize assembly line in a dedicated factory, and then to bring all these modules on the field to build that very fast. And I think it's a challenge for us in nuclear. Some players have begun to do that in the past, also in big plants. I'm thinking of Korean or Westinghouse on the AP 1040, but on some parts of the plants. And SMRs is pushing the logic much further if you want to be competitive. So I think it's a challenge for the designer, for the developer, and for the supply chain.
Thank you. Jay.
So I would agree with Rumina on the goal of harmonization, and I applaud you for the connections you've made, and I'm looking forward to that tri-party agreement. I think that unlocks a lot of opportunity to standardize once you have a common set of regulatory requirements you have to hit, and that will lead to a supply chain that's more repeatable, designs that stay standard and simple and cost-effective and can be delivered on time. So I think that the harmonization is what really resonates with me.
Thank you. Dominique.
Oh, yes, I think standard design is helpful. I think it's very needed. As much as we can, I think we need a standard design for a lot of places. It will be better. Just we have to keep in mind that the last tentative to harmonization was a failure. It could call the name was MDEP. It was a failure. So because it was tried to embrace too much. So if we start by embracing less and to be more focused on some important goals, I think we could succeed. But we have just to be careful about that. Mainly because if we try to standardize too much and to have too much standardization of harmonization, we will slow down the speed of SMR, and it goes back to my previous point between the challenges between nuclear challenge issues, nuclear climate, and harmonization. I would prefer we focus on nuclear climate. Of course, once again, standardization will be very helpful and will be. But once again, we don't need it specifically. We could speak a lot about golden eggs regarding future of SMR, but if we don't deliver the hen at the first, we will miss the target. We have to focus. My chief nuclear engineer who is there knows that very well. Always on time and on schedule for the first of a kind. And it's already a big, big challenge, I can tell you, because there have been no success in the Western world so far.
Thank you, Dominique. Evgeny.
Yeah, at the beginning you have mentioned that for quite a long period I was a manager of heavy industry companies. And I can assure you that from the production point of view, the manufacturing of the equipment for SMR is not easier than for the large scale NPP. You have totally the same safety requirements and manufacture is quite complicated. Luckily, in Rosatom, today I can say that for our existing design, we have the supply chain because we have already produced, as I said, 6 units of Rhythm reactors and 10 more are in manufacturing process now. But I totally agree that good supply chain is crucial to have such supply chain, and which is more complicated is how to involve companies from different countries in this supply chain. And for sure, in this case, the most important thing is standardization. But also, I believe that also very important thing is to have the trust from the industry, because we speak a lot. We, for years, describe our plans for the construction in different countries for different projects, but industry, they don't need some paper projects. They need real projects, and they, moreover, they need to see the pipeline of projects, because they need to invest, they need to be prepared for this process. And this is the most challenging thing, I believe.
Thank you, Evgeny. Simon.
Yeah, thank you. For us, I think standardization is probably one of the most important things, and it has to be standardization of a simple design. Simple to construct, simple to operate, simple to decommission, because otherwise you don't get thousands of reactors in hundreds of countries, right? And, you know, factory build, which a lot of people talk about, for us is not really about economies of scale, it's about speed and simplicity. We should be knocking these things out like cars, right? And then shipping them around the world. They should be able to be constructed in whatever market has sufficient volume to make it worthwhile, which means they should have very simple components that are easily accessible by a vast range of manufacturers from all over the world. And so the core of it for us is that standardization, which drives speed and drives down cost. And I think a lot of the other constraints will then, to some extent, fall away, because, you know, I think the point that Rowley was making is about market demand. Once the machine is there, the simple machine is there that gives you clean energy at a low cost, market demand will force the regulation through. And so that's the future we hope to see, which is the same one I think Romina hopes to see, which is thousands of reactors in hundreds of countries.
Thank you, Simon. And now, the last round of questions. One quick question, one quick answer. First of all, let me thank you, all the colleagues, the distinguished speakers, because they were really very brilliant. Let me conclude with one good reason to go SMRs and one key priority to be solved or to be addressed for the SMR and AMR deployment to be successful. Romina.
So even though we've said not to talk about it, I think one good reason is SMRs are safer. They just have, as we've heard, these passive systems that will mean no operator intervention required, no need for evacuation zones. So if they deliver on what's being proposed, I think from a safety regulator's perspective, the simple ones where the safety, security, and safeguards is by design done up front, will just make it a much better machine. The one challenge or one priority area, which we've also heard, is building of public trust on why this is so critical and how it can help meet our bigger goals.
Thank you. Rowley.
Okay, I'll skip the safety thing. I'm going to talk about the communications point of view. I think that the most efficient or a reason why go SMR on that perspective is the potential new use cases for these reactors. So for heat and hydrogen and all this stuff, they are perfectly suitable for these cases. And the thing is that from a communications point of view, if you bring this up, you're not against any other clean energy. You're not against big reactors. They have their use cases. You're not against wind and solar. They have their use cases. But there's a missing piece of the puzzle, how to do steam, how to do district heating, how to do desalination at the scale that's locally needed. So I think that's from a communication point of view, that's the kind of powerful angle. And well, what's needed? Well, regulation and legislation need to enable these use cases. So if it's illegal to put an SMR next to your industrial park or your city to produce energy for that, then it won't happen. So we need to enable this.
Thanks. Dominic.
as already speaking about the first point, I will discuss on the second point. Conditions of success, I think two in front of us, because they are not so far done. First, to design simple. If we don't design simple, there is no future. There is no possibility of competitiveness. Second point, to develop completely the design before constructions. I think it's a big lessons learned for the existing new nuclear projects. If you start construction and you have not finished the design, it's a mess. So really to finish constructions, to finish design before construction, that's the very key condition of success.
Thanks a lot. Simon.
Yeah, I think the answer to the question why SMRs is, what else is there, right? If we're going to solve this problem that we have, it's that or carbon capture. And we don't know whether carbon capture works yet, right? So there are net zero strategies emerging in countries around the world like the UK that have a pretty heavy reliance, unwritten reliance, on the success of carbon capture. And we don't know if it works, and we don't know how much it's going to cost. So what else have you got would be my reason for SMRs. And then the challenge is to behave as though this was really an emergency.
Thanks. Evgeny.
First, about the reason. I think that SMRs can be built in areas which are traditionally not suitable for large-scale NPP. And it means that more and more countries can get access for this international nuclear club, and more people can get clean and affordable energy. And about challenges, yes, there are a huge amount of challenges on our way, but I spent a lot of your time at the beginning when I spoke about floating NPP. And I really strongly believe that this is a real product which is ready for supply today. And, but on the other hand, we see a lack of international legislation in this field. It's necessary to agree how to transport this barge, how to operate it, how to take it back, how to refuel it. There are a lot of issues which should be solved, and in this case, we will get the chance to use this product now.
Thank you. Jay.
So for me, the one good reason is simple: the environment. For our children, our children's children. Nuclear is going to be the only way we're going to get to where we need to be. It's another reason, speaking toward diversity and attracting youth. When I get interns in, they want to come to a place that makes a difference. So for me, that's the one good reason. That's sort of our vision out there, our purpose. The one challenge I'll use two symbiotic words. So cost, right, and certainty of outcome. We talked about the need for simplification and standardization and harmonization. All those things are needed to get at a competitive product. Really, really key. The other piece of this is certainty of outcome. GE's been delivering units for many decades. I also have to say that our steam power colleagues have their equipment on half of the installed base, 200 gigawatts out there for our steam power team. So we've done this, and now we've got this approach for, on time, on budget, certainty of outcome. That's what we've got to go after and prove to the world that we can do. But I'm very confident and excited that that's exactly what we're going to do.
Thank you, Jay. Renaud.
Yeah, a good reason to SMR. Sorry to copy the others, but we have a date with history, I think. And it's completely out of date to oppose renewables and nuclear. And I think it's also out of date to oppose big plants and SMRs, even if some people play this song. And the world will be really better off if we had several competitive SMRs on the shelf in the future years. And one key priority, I would say my first priority obviously is to take the challenge of Dominic and to be on time and on budget on the first of a kind and to be ready for hundreds after that. But the biggest challenge I think is cooperation. Cooperation in all directions. We have to cooperate with all the supply chain to be ready to be in different countries with a standardized design. We have to cooperate with Jay to discuss together with our safety authorities and institutions in Europe, in the world. We have to cooperate in all directions, and that things it's something quite new or forgotten, perhaps, in the last decades, that we have to go further now.
Thank you. Let us conclude. I think that the number of people that are here is a clear indication that of the interest that is around the SMR and the advanced reactors concept. I think that we all get a lot of information and inspiration from your speech. So I would like to conclude the panel with a big applause to the speakers because they were really brilliant. Thank you. Thanks to everybody.